time for the official start of the webinar and its recording. So we have the red light on. Good afternoon, everyone, and welcome to the last of 12 EMOS webinars. My name is Mojca Baudaš. I come from the University of Ljubljana in Slovenia, where this session is hosted, and today I'll also act as a facilitator. Now, I assume most participants are familiar with EMOS, the European Master in Official Statistics, that is a joint project of universities and data producers in the EU member states, EFTA and EU candidate countries. The network of 23 master programs in 15 countries is expected to grow soon. Applications, as you can see here, the third call for applications is out, and applications are still accepted until the end of the month. Now let me explain briefly how we run the webinar today. As a participant, you can watch and listen to the session. To interact with the presenter and me, you can use the chat window on the right, where many of you already said hi. We really encourage you to post questions here throughout the webinar, and the presenter will respond during several question breaks. Should you have any technical issues, I'd advise you to first try restarting the Adobe Connect or the computer, because mysteriously this usually solves all problems. Now, today we have a privilege to host a distinguished guest who greatly contributed to the birth of EMOS. Walter Radermacher used to be Director General of Eurostat and Chief Statistician of the European Union. That was between 2008 and 2016. Previously, he worked for 30 years in the Statis, the Federal Statistical Office of Germany. He was also the first chair of the UN Committee of Experts on Environmental Economic Accounting. And more recently, he's been affiliated with La Sapienza University in Rome. And he also became president of FENSTATS, the Federation of European National Statistical Societies. Now, in many webinars here, we heard about the challenges that official statistics is facing in this disruptive period of time with data all around us, and how to deal with these challenges and what's the future of official statistics. I think our guest may have some answers. Walter, please, the floor is yours.
Thank you very much, Mojca, and good afternoon, or in Greece it might be already evening, or in Mexico it might be good morning. So hello to everyone. Thanks for the nice words, and indeed the reflections that I would like to present to you today, they are of course a collection of impressions and lessons learned over my many years in official statistics. And so I would like to share with you some thoughts about the very nature of official statistics, and then coming to the conclusions, where are the main challenges and how could we respond to the main challenges in the next years and for the present time. I have structured my presentation in some sub-chapters, and we will have a short break after each sub-chapter or chapter, which gives you the opportunity then, as Mojca has said, to pose questions and gives me the opportunity to, let's say, to directly interact with you. But let's start now and see how it runs. It is also a new experience for me. It's like coming from a theater to film production, because I can't see the people in the classroom. But I hope very much that a quite lively interaction will come up within the time of my presentation. So let me start with the first slide, which is for me a kind of symbol of the paradoxical situation that we are living in. Moita has introduced the seminar with the words that data are all around us. So we are living in a digital age, on the one hand. On the other hand, people are not really able able to follow all the facts and to understand the facts. And thirdly, in the private sector, but also in the public sector, the pressure is very high that all the projects that you run and all the activities have to be defended by so-called facts, evidence-based decision making. So these are the three, more or less, the triangle of three conflicting situations of our current time. And facts are confusing me. A photograph from a Saturday morning in my hometown, Wiesbaden, is a symbol for that situation, which is quite puzzling for statisticians in all fields, in particular in official statistics. Now, first question is, what is official statistics? Of course, the quite simple answer is official statistics is statistics produced by statistical offices. This is what you hear quite often. It's not completely wrong. And maybe we need to look a little bit closer to a definition which elaborates more this thought that official statistics is statistics produced in the public sphere for the purposes of public decision making and so forth and so forth. So my definition of official statistics starts with answering three questions. The first is, who is producing statistics? And this is, as I have said, it's produced by officials in statistical offices, means public administration. The second question is, what is produced? And this is quite important because it leads to the decision on the statistical program and the priorities, which are quite important for the selection of statistical variables and statistical programs, as I said. And at least in Europe, it is legalized by European law that the final decisions on the statistical program are taken by the legislator. So there is a huge consultation process year by year on the annual program and the 5 years program, and finally it is the parliament that decides on the statistical program. So this is a kind of democratic feature, democratic basis, which is quite important in current times. And this is very often forgotten when we talk about official statistics. The third question is, how is statistics produced? And the main catchword here is quality management, quality management systems, and ethical codes. I will come back later to this, but the quality promise of official statistics, the guarantee of official statistics is very high, and it should distinguish official statistics from other forms of statistical production. So these are the first three main features of official statistics. Now, there are three more, namely when, where, and whom, when we look at the so-called national statistics paradigm. As we know, statistics was born together with the nation state as a baby, as a child of the Enlightenment at the beginning of the 19th century, end of the 18th century. So it is quite normal and very often forgotten that all our statistical programs, that they are produced within the system boundaries of a nation state. And they are produced for the needs and the information request of the nation state. And they are addressing the features and the subjects in the nation state. And in addition, it is then focused on one period, a year, a month. So we have a combination of national statistics are time slices, year or month, normally, in one country or in one region. Sorry for the Mexican colleagues. NUTS is the regional administrative classification, the nomenclature of administrative elements, geographical elements in Europe. And the resident population is normally what we observe in both economic and also demographic statistics. So this is a definition that I think is rather complete if we want to define official statistics in the form of national statistics as we know them today. When it comes to international statistics, then we have normally something like here in this slide. The European Union does not produce statistics itself. It's a kind of sum of the national statistical cubes of the member states or the member states of the European statistical system. So the EU member states, but also Switzerland and the EU EFTA, the EFTA EEA states like Norway. And now the question is this a problem? Obviously, in the past, it was quite natural to produce statistics in such a way. But now we are in a world which is globalized and digitized. And you see here some arrows which highlight problems with a couple of features for the definition or for the way of producing statistics by now. So, for example, if you look at sustainable development, there is a problem because sustainable development tries to connect the well-being of the current generation with the impacts on future generations. So we have a problem with the time slice of the observation time of statistics as we use it. But sustainable development should also connect the impacts from activities in a European country, for example, to the population in a developing country where products are produced, say Bangladesh or Brazil. So we also have a problem with the system boundaries when they are too strictly focused on one country only. Globalization has the same creates the same kind of difficulty with the statistical system as we know it. Geospatial data arrive in a form which is, let's say, produced by satellite images, by remote sensing, which means that their natural boundaries, their natural character does not include administrative, geographical, geospatial boundaries. So there is a normal difficulty between geospatial data and the classical administratively clustered statistical data as we know them. Last but not least, if we focus too much on resident population, then we will have a problem to cope with migration, for example. So if people from Romania work in Italy or in Spain, then we need to mirror the migration flows from one country to another in order to have, let's say, a sound demographic statistics in official statistics. So just to mention a few of the problems that we have currently with the national statistical paradigm. So this is the first break. If you have any questions, then I would be happy to answer now.
I don't see any questions so far. I would just like a short comment. Now, this definition of official statistics seems very appropriate for our context, the European context. What about, would you apply it as a global definition of official statistics?
Well, thanks for the question. I think I'm quite sure that it can be applied to to a global scale. Take a country like Australia, to take an OECD country, or let's say Bangladesh, or Ghana, or Argentina, to take just a few. And I think the main features are the same. Why? Because the main structuring element in statistics is national accounts, for example. And if you look at national accounts, they are exactly produced as I have described. So it is 1 year normally, and it is the activity, the production, consumption, and income in 1 year in one individual country. And globalization means that the value added that is produced in this country might be quite different from what we account for now in national accounts. So we see, I'm quite sure that the way of approaching official statistics in such a way, official statistics, one, and second, to look at the national form of official statistics can be applied to any country around the globe.
Okay, thank you.
Okay, then let's enter something which normally creates a bit of a problem for statisticians, because this is the very philosophical basis of our profession. And I know that this is not so, that statisticians are not that familiar with it. So let's focus on the very, very, very fundamental things, and I try to explain them in a let's say fast movie, fast track feature. So what is the relationship between reality and data? What do we mean when we say a model? What do we mean when we say knowledge and theory? But at the end, it's all about the question, are facts coming from official statistics the reality? Are they true? Or can they be false? What do we mean with errors? And I think it's really worth entering this world, because it leads to much sharper terminology and avoidance of erroneous terminology, which creates over expectations as regards our results. Now, I already mentioned that statistics is a child from the Enlightenment period. And I have used here now 2 Germans and a book which has been written, which explains the 2 guys who lived at the end of the 18th, beginning of the 19th century. The one was the famous mathematician Carl Friedrich Gauss, and the other, one of the 2 brothers of von Humboldt, Alexander von Humboldt. And if you have not read the book, I really can recommend to read this book. So it should be standard literature for each statistician, I think. Measuring the World from Daniel Kehlmann. And he describes how von Humboldt traveled around the world. So you see here his journeys to Latin America in particular, where he collected in an empirical way a lot of data, and he was the explorer, the discoverer in his period of time. On the other side, we had Carl Friedrich Gauss, who was a very introverted person, a real mathematician, and he would have preferred to stay in bed and to think in his bed and to imagine how the world would work. So he was the guy of pure theories, whereas Alexander von Humboldt was the person with the empirical approach. Now, what I want to say is that if we characterize statistics as the profession that means learning from data, then we should always have in mind that learning from data is not either or only theoretical concepts or empirical collection. It is this permanent dialogue between theories and data. So if we look at statistical theories, for example, we have this learning moment in Bayesian statistics. So I think here we have the two guys who can train us in understanding that it's always an interaction and evolution where these two components play a basic role. Second question is, what do we mean when we say measurement? And I start with natural phenomena. And here you see a quote from Norbert Wiener, who said, the best material model of a cat is another, or preferably the same cat. Which will say that we cannot really mix up the reality with a model. A model is always a simplification. And a simplification is always asking us for conventions, for priority setting, for choices. And it's even worse if we go to social and cultural phenomena. There we have a guy from the beginning of the 20th century, Max Weber, who introduced the so-called ideal type, a basic approach for social sciences. And in his sense, we have also to distinguish between measurement, which would be an appropriate term for natural phenomena, and quantification, which is the right word for cultural phenomena. So if we measure, let's say, the size of a child, then we take a meter and we can measure. But if we want to quantify, let's say, income, then we income is in a way that can then be quantified. So distinction between measurement and quantification is quite basic for statistics. However, this is not a very sharp definition. Unfortunately, there is a huge overlap between these two. So if we measure, for example, trees, and we quantify something like forest, then it's quite clear that there is a huge overlap. Or if we conduct a population census, then we can say the counting of people is measurement, but the quantification of families and their income or living conditions is quantification. However, these two have a huge overlap. Now, the next one is complexity. I have 3 or 4 slides in my presentation which are not meant to be, let's say, now read in my presentation. But if you are interested, please go back either to the slide or to the book, which is Alberto Peruzzi, in a nice book from Filomena Magino from last year, Complexity in Society, where you will find the links between complexity science and statistics. And I think it's really worth for statisticians, if you have spare time, to dig in a little bit what means complexity, because the world around us is full of complexities, and it's much too easy for statisticians to assume linearities where we have complex feedback loops. And this would then lead to wrong concepts and a wrong design of statistics if we are not aware of the complexity of the features that we would like to measure. And reduction of complexity is, of course, our profession. So we go from data to information, and from information to knowledge, and we reduce the complexity. We do this by using our concepts, but there are limits. And the limits are then here around this sunflower. So, for example, we have clandestine phenomena which cannot be measured. or opinions, prices without markets. Things might be too costly to be measured or quantified. But all of these limits are depending on time. So what is quantifiable today or last year is much more than we could quantify 20 years ago. So it's a moving target. But there are limits. So time for questions.
Yeah, I would invite our participants to pose questions. Obviously, we're just listening. Any questions from the audience? Well,
okay, maybe after the next one.
yeah, but I was just thinking, nowadays it's quite acceptable that you can go from data to theory, not only from theory to data. For a while, I think that only the first one, well, the approach from theory to data was kind of permitted or acknowledged as the right one. Of course, because of the fear, that you're fishing for results. But I think nowadays, especially with so much data around us, the other option is also at a let's say more equal level in terms of how recognized such research is.
Well, I wouldn't have a problem. Thanks for the question. I wouldn't have any problem as long as it is equal, as it looks like this loop here. No? But if you speak with data science people, I think it's not equal. They are really naive. They believe that you only have to look at the data, and the data themselves, they can tell you something meaningful. And I think this is completely wrong. Without any kind of hypothesis, a model, an assumption, of course, the gold is in the data, clear. But in order to filter out the gold nuggets, you have to define what is gold. And so it's impossible really to run only the data and come to meaningful results. At least for official statistics, you always need to have a kind of knowledge determinant in mind. Where do you want to go to? What kind of question do you want to answer? What are you looking for? And without any kind of simplification of in terms of a model, for example, scientifically speaking, there is no way that the data can tell you any kind of meaningful impact. So it's simply noise without any signal that you can spot. But I think this is now for statisticians an opportunity. If you speak with data science people, this is the message. We statisticians have always combined theory and empirical approach. And we should train our colleagues from the data science that this is the right way to do it and not waiting for the eternal truth coming from the data. Okay, but...
okay, we got one question. Would we be talking about a socio-epistemology that provides us with a theoretical approach whose thesis is primarily to account for knowledge through the social practices of the human groups that made them possible? Okay, maybe I have to reread this, or you can have a look at the chat.
I know what Paul means.
Yeah.
I know what Paul means. So I think in sociology or in epistemology, you have, in principle, two extreme positions. The one position is, let's say, simply speaking, realism, where you believe that you can, let's say, observe directly the reality. And the other is relativism, where sociologists say, whatever you observe, it depends on your concept in your brain, in the concept of your science. And these are the two extreme positions. So a naive realism and a kind of assumption that the world itself at the end does not exist without any kind of, let's say, glasses that we use to understand the world. And I think we statisticians should find a way in the middle. Let me say, okay, this is my personal opinion now, really Walter Radermacher's opinion. There is a world outside that we have to observe and quantify. However, the result of quantification depends very much on the science, the model, and the assumption that we apply. So it's no way that we can separate the reality from the observation. So whatever we do, we will have an influence on the observed object and the people who are observed, and we are influenced by the world around us. So there is a kind of co-production of statistics and society. This is, I think, the mainstream assumption in sociology today. I come back to this in a second.
Yeah. Please
continue. Then let's move on. And I think the question now is, if we look at the factory, the making of statistics, how is statistics produced? Then I think it is important to separate 3 or 4 main processes. The first process is the design process at 12 o'clock of this chart. The second one is the production process itself at 3 o'clock. 6 o'clock you will find communication, or you might say dissemination. And at 9 o'clock you have the transformation then to knowledge and use on the user side. So if you keep this in mind, then of course you understand that the quality of the final statistical production, which is the quality at the very end, at the use of statistical information, depends on the quality of all these processes, of all these steps. It's not only the quality in the production itself. If your design of the statistics is not optimal, if the design is really not giving an answer to the question that you would like to answer, then the production might be completely okay, but nevertheless the quality of your product is not good because the design is not okay. The same applies to communication. So your statistics might be completely fine and without any errors. The design is okay, but if you communicate them in a non-understandable way to the users, they might draw the wrong conclusions. So this means that the concept of quality is looking at all these 4 processes in one. The second is that we have to distinguish between different layers in an information pyramid: basic statistics, accounts, in particular national accounts, and indicators. They all serve different purposes, as we will see in a minute, and they are, let's say, also covering this kind of funnel of the way from data to knowledge. Now, if quality is multidimensional, and if we want quality to be, or if you want statistics to be relevant for the questions that we have got, so high relevance for policymaking, we want them to be consistent with the theory, and we want them to be measurable in high quality. Then we have indicators, accounts, and basic statistics, and we see they are at different positions in the intersection between these 3 types of objectives. Indicators are clearly closer to be policy relevant. Accounts are very much driven by theory, macroeconomic theory, and basic statistics are much more close to the measurability. So if we cannot give answers with one product in the portfolio of products of our factory, then we have to be aware that our customers and our clients may profit from different products that we provide. So our supply side, our product portfolio is composed of different elements of different products, which is a huge advantage of official statistics. But we sometimes are not aware that this is the case. Now, what is the DNA of official statistics? This is a kind of summary slide. So statistics, in official statistics, they are manufactured products. This is not the same as scientific products, pure scientific products in an academic institute, for example. So we are in factories and producing manufactured products which are designed, produced, communicated, and used. Like a car, like a bottle of beer, like a hamburger. Statistics are products. And this is quite an unusual perspective for many of my colleagues in official statistics. But I think it is important to take this as the reality. Data is the raw material for these products. So we should distinguish between data and statistical information. I think that's very important, that we do not cover whatever kind of talk we have with data. Data is everything. No, data for me is the raw material. It's like crude oil, where the information is included, and what we produce is information extracted from data. So I think that's the main part of this slide. The second is we are living in an evolution. So it's not that we produce statistics every year from scrap. We do not start with a white sheet of paper. No, we have 200 years of evolution behind us. This is a big disadvantage because we are so rigid and inflexible. On the other side, it gives us democratic legitimation, and in this evolution we can develop slowly, but we can do this in a very solid and democratic way. We can move to the next generation of statistical products. This is quite important to understand. Quality, number 3, is that quality has to understand that statistics is not only produced as a language for statisticians, but it should be communicated in a language for non-statisticians, so users, which means in terminology of sociology that we are dealing with boundary objects, a language which is not expert language, but a plain language, like something like the English that we use in this webinar. So my English is not the English that is perfect, but I hope as a boundary object that all of you can understand me. This is what we have to have in mind as statistical language. And well, the quality of statistics depends on the fitness of the production process, the communication without misunderstandings. Of course, we need to look at the conditions. Do we have enough money for the production of statistics? Is the political environment okay? Are we independent? And so forth. So this is more or less then leading to the question of governance in public administration. And this is here the last one, quality safeguards. This is now less familiar to the Mexican colleagues, but it should be quite familiar for those coming from the European countries. So in Europe, we have quite a number of quality safeguards who have learned from what has happened in the last decades with errors and mistakes in statistics. And these safeguards are protectors against, let's say, wrong quality or, let's say, insufficient quality in official statistics. But you might wish to read this slide after the presentation. A break.
Yes. Any questions, please? I'm not sure if you will deal, while we are waiting for questions, will you deal with communication a little bit later on? Because
I think so, yes.
Me as a teacher, you know, I'm in contact with students, even colleagues, and we often see this lack of perfect communication between official statistics end users. So I would be very much interested in your opinion on that.
Yeah, come back to this.
Yeah.
There is somebody typing, but maybe we can continue and come back
Okay.
after the next break because
Yeah.
time is a bit running.
Yeah.
Now comes the chapter which is called three sigma. And the sigma is not only for the Greek colleagues. It's science, statistics, and society. And this is a quotation more or less from a branch in sociology, which is dealing with the interaction between engineering, technology, society, and science. And if you look at statistics as a kind of engineering, a technology, then we can profit a lot from what the engineering sciences have learned over the last 20 years. So I've looked a lot into the literature here, and I have understood that official statistics is always a kind of coming together of these three driving forces: political driving forces, scientific driving forces, and new data. And here you see a kind of 4-period slide for the official statistics 200 years in the past. So the 19th century, where we started with empirical research, beginning of the 19th century with analytical statistics, so Carl Pearson and Gini and these guys, and the 1970s then with the introduction of computers. And now we are living in what I call the blue phase, which is then the digital age. And I think everything is changing around us, like it was in the breaks in the earlier periods. And as I said, for me, it's always a coming together of three driving forces: science, new forms of measurement, and also new political drivers or new societal drivers. And sometimes it's a little bit more on the scientific side, sometimes a little bit more on the political side, but at the end, it's always a kind of amalgam of these three types. Now, the world we are living in is characterized, in my view, by three revolutions. The first one is the well-known data revolution. A word from the Royal Statistical Society, the Data Manifesto from 2 years ago, where it is said what steam was to the 19th century and oil has been to the 20s, data is to the 21st. I think that's well known. The second is the revolution of evidence-based decision making. Less well known, or we are not aware that this is a revolution as well. But if you now run an office in somewhere in the western part of the world, it's impossible to not have key performance indicators for your management. So the world is full of indicators for management. So we have changed from administration to management. And this is a revolution, a very silent and stealth revolution, as it was said. But now it's taken for granted that it's certain that if you can't measure it, you can't manage it. But if you turn this around, the sentence, then it's quite obvious that this is a kind of mantra, which is an ideology. So, and we are not aware that we are living in this idea, under this ideology. But it's very important for statisticians to be aware that this is an ideology. The third one is a reaction on the second one. And this is what we currently observe, the post-truth politics, or facts are confusing me, as it was said in the first photo. And here is a quotation from the now President of the United States in his election speeches. He said, "The 5% unemployment figure is one of the biggest hoaxes in modern politics." Donald Trump 2 years ago. So, and this is the counter-reaction to the, let's say, the overuse of facts in the second revolution, the third revolution. And we are living in this paradox world. And, well, the second quotation here makes it very clear. During the past 100 years or so, political governance underwent a massive quantitative turn. This quantitative turn here is understood as systematic effort to delineate and measure the objects and results of governance quantitatively for the purpose of demonstrating competitive edge and superiority at the individual and or collective level. This is the quantitative term, or the audit society, as one author said. And we statisticians are very often asked to measure things where we say, hello, this is not measurable, but the pressure is so high that we somehow try to defend ourselves. But this is not a right position. We should really be very proud to say, this is not measurable, period. But this takes a little bit of courage. Now, de Rosière has elaborated a little bit the forms of the state. And you see here that after the engineer state, the liberal state, we now are living since the 1990s in the neoliberal state, a form of governance which we take for granted as the one and only form that is possible. But I would warn that this can change quite rapidly. Now, knowledge is power, as we know. I move on a little bit to come to this slide. Goodhart's law. Charles Goodhart was an economist, or is an economist in the United Kingdom, and he said there is a feedback loop. When a measure becomes a target, it ceases to be a good measure. So there is a kind of counter-reaction. What you measure reacts on your measurement. And this we have seen in quite a number of examples, that the simple assumption in a treaty called Maastricht Treaty, where the politicians had introduced thresholds for the public debt and deficit, 3% for the deficit and 60% for the debt, out of a sudden made public finance statistics super sexy and attractive. So there were troops of advisors from big banks going to the countries, advising the countries as to how one could circumvent these measurements. So what Goodhart says is a reality. So whatever we measure, it has an impact on the behavior of societies. Quite important to bear in mind. Now, limitations in communications. This leads a little bit to Moitzar's question. Where are the limitations? In numeracy, on the other side, on the opposite side. So if the society is not literate and statistically trained, we have a problem. If politicians come with completely erroneous, wrong expectations, then we are in a defensive position and we might be pushed to produce statistics, although we believe it's not the right way to do it. We have a problem if the normal consumer does not have an appetite for quality food. It does not help us if we produce the 3 étoiles Guide Michelin cuisine, so the good restaurant food, if people go to the McDonald's around the corner because it's cheaper. Scientific overkill. So scientists can be simply too demanding that they come never to an end. And. So you see here a lot of problems which are limiting our possibility in communication. If we want to improve communication, we have to deal with all of them with regard to different user groups. So, but basically it's statistical literacy that we should promote. And we have to invest much more time as statistical offices in cooperating with the education system, with media and so forth. So here, Bart Simpson, what is GDP? is quite a symbol for the reality. If you ask your neighbor, could you please explain what is the inflation rate, or what is GDP, or how is employment defined, you would be surprised how wrong the answers at the end are. A break.
Yeah, we have a question from the Statis. In furthering government transparency, should the product portfolio of official statistics move in the direction of dissemination of the raw material?
Can I come back to this after the next?
Yes. Yes.
Yeah.
Of course. Maybe I will just now stop for a second. Yeah. Actually, we are back, so we can continue.
Okay. Last chapter. This is now the digital age. Statistics 4.0. What is important? I think it is important that we understand that it's not only technology that we have to understand, not only mathematics and statistics, not only domain knowledge, but it's the intersection of all the three. And it's a little bit more elaborate here in this profile of data science role: domain knowledge, technical programming, mathematical statistics. So also the EMOS program of the future should look at these slides and say, okay, do we have enough of all these elements? So the skills composition of statisticians in the future will have to change. We have to go beyond processes, and we have to understand what are the real misunderstandings. For example, if we talk about indicators, because indicators is such a mushroomed buzzword now, that if you use a word like indicator as a statistician, you have to be extremely careful, because immediately you are in a deep ocean of possible misunderstandings. And the second part here, dominance of the technocrats, leads then to my third counter-revolution. And there is a nice article in The Guardian where a guy called, now I forgot his name, he has written a paper where he highlights the fact that people don't understand what is the GDP, the artifacts. They have a huge distance to top-down classifications. This leads a little bit to the German question. I will come back to this. National aggregates and national averages, like employment or GDP, they don't tell anything to individuals and their respective local environment. So if you say the average inflation rate is 1.3, but your pizzeria around the corner and your haircutter are completely different in their price policy, then you don't understand this high aggregated average. And in times of big data, this is what we have discussed a minute ago, a data logic might replace a statistical logic, so that you believe that everything is already included in the data. So, and now I come to the name. The guy who has written, but I can give you the quote, is Michael Davis, Davies, in The Guardian last year. A very nice article, but I can give you the quote afterwards. Now, we have to protect official statistics. We have to ensure with good governance that official statistics remains relevant for policy, but it's not politically driven. And this is a right on the, let's say, razor edge. Huh? So it's very, very difficult to get this in a correct way. We have to understand that official statistics is a public infrastructure where good governance plays an important role from a democratic civil society perspective. In terms of the relationship between the courts, the judicial system, and the statistical system, we have to insist that official statistics is the final authority concerning statistical classifications. So it's not possible that even the Supreme Court of a country interferes and says, Well, this classification of the statistical office is incorrect. But we have had cases like that. And then, of course, we have to ensure that we deliver value for taxpayers' money. And this is also then a little bit leading to the German question. The output of the statistical program is completely tax budget financed. So the choice of the method, the choice of the program, and finally has to be a reflection on the fact that we get all our money from taxes. Some principles for the new enlightenment. I will jump over this and come to the last slides. We need to review the national statistics paradigm. Now, coming back to the very first slide, and I have explained that globalization might create a problem for statistics. So if, for example, because I know we have also Irish participants, if the Irish GDP 2 years ago or 3 years ago went up by 25%, more or less, by the move of one global enterprise from outside Europe to Ireland, then we have got a problem. And macroeconomic indicators really have to be looked at and redefined in terms of globalization. The same for sustainable development. It might not be sufficient that we add up national solutions because there are questions like climate, the oceans, biodiversity, which are not, let's say, cuttable in national slices because they are global by nature, and so forth. Now, communication. This is Mozart's question.
Yeah.
Communication, I think we should learn from the industry, and we should have real market research on our products. This would be, for me, the starting point. What do users expect? What do they currently do with our products? And where are the misunderstandings? What are their wishes? What are their misconceptions? And so forth. And I think really that we have missing evidence. If we compare ourselves with the industry, then they could immediately answer the question, can you prove how your indicators are used, how your statistics are used? And we are by far not there. And so if we really want to improve communication, this is the first step, market research in statistics. The second step is that we go back to our four processes: design, production, communication, and use. And that we understand that in all four places, communication in the future must play a role. So communication in the design of the products is very important. And this goes a little bit to the German question. So for example, if we set up an indicator list for sustainable development or for something else, then I think it is the best practice that we should follow is the one from the ONS in the UK, when they introduced the subjective well-being questionnaire in 2011. They have used 1 year to consult the civil society, really to learn from what are the indicators that we are looking for, how could we really improve the program. So in the design of the products, we should do all the best to include communication with civil society. The same for production. So there are platforms where you can include in open platforms all kind of collection of data from civil persons also for statistics. So they could, for example, there is a platform called Eye on Earth, where you can feed in what you have observed in your ecosystem around you. And this can then be chosen by the statistical office, whether it is taken into account for the production of statistics or not. Communication, of course, this is what I think you have had in mind, Moitza.
Yeah.
It should be smart, it should be open. We should use all the instruments which are currently developed in the cooperation of statistics among statistical offices, but also with data journalists and very, very clever media who can help us to have improved communication. Last but not least, feedback loops. They could be very short feedback loops. So if a professor gives a feedback loop and says, there is an error in your figure, please correct, this is a short one. But you can also have a long feedback loop on the program itself, where scientific people or private people give you hints where your program could be improved. The last one would be then enhancing reflexivity. This is the intention of my presentation today. So really to reflect about our profession. So I have a very broad approach to communication 4.0. Last but not least is governance 4.0. We should also take into account that in the future, our link between, last slide, between the society governing through information and we are governed through the society, that this becomes more complicated in the world we are living in. Because new technologies have an influence on the citizens. Take the iPhones. The processes of information construction are changing, algorithms, and so forth. So the governance needs to take into account much more complicated interaction between different loops. And for example, in Europe, the code of practice needs to be revised in such a way that we take into account all these elements. Open questions, statistics and data science, who takes the lead? Professional values and ethics, code of practice, what is the future? The fourth one is ethics for decision makers and also ethics for media and journalists. Is this important? Statistical competence, how could we improve the cooperation with the education system? And international statistical governance. Do we need something like a UN law on data? Global conventions, which do not exist at the moment. The last slide is this one. I think we have proven that we have really managed that three fundamental rights were protected by statistics: data protection, freedom of information, and statistics. And that this is a good starting base to defend our case in the current situation if we continue this success story for official statistics of the near future. That's it. Thank you very much. Now waiting for more questions.
Yeah. Now questions are coming in at a higher rate. So I'll start by a question by Roberta Pignatelli that refers to indicators. So she says, the misunderstanding about indicators is not only by a society with a poor level of statistical literacy that you mentioned. Even if in a scientific environment, unfortunately, we have the same problem. I work on environment indicators and I would love clear definitions. I usually refer to the UNSD definitions, Framework for Development of Environment Statistics, and she's asking, is there any other specific definition? So it's a very specific question.
Yes. Well, the answer is the debate is ongoing, and on Friday we will have a seminar in Rome, not that far away from you, and co-organized by ISTAT, and it's taking place in La Sapienza University, which is dealing exactly with your question. So how could we handle the difficult situation of, let's say, a proliferation of indicators? On the one hand, unclear definitions, which is very risky And so if you have time, come to the seminar in Rome. I think it should be possible. For the others, um, I think what I could do, I can share my presentation from Rome as a PDF so that you can look at it. I hope that is then answering a few of the questions from Roberta.
Okay, thank you for this information. Then Rudy from Mexico says, now everything evolves very fast. New needs, new technologies, new tools and actors, new competitors that generate better information. For example, Google. So what would be the recommendation so that statistical offices are not left behind?
Okay. The recommendation is firstly to understand what is the core and the DNA of our very profession, and where are we after 200 years, and what is our business case that we can sell. I think I've tried in my presentation really to approach this question with an answer. And once you have got this answer, then you can go to the public and say, okay, look, this is our business case, and this is why you need us and not the Googles. Because what you will get from Google is not consistent over time. It will not give you the answers that you would need. So if you dream that you can calculate the GDP by looking at the night lights in countries, which is a promise of one of these super data science people, then let's have a kind of hackathon where we sit together, and then at the end you will see Mr. Minister of Finance or Minister of Economy, which GDP you would like more. So we are like the fine cuisine cooks, and we are attacked by the McDonald's low quality food people. But we should not lower our quality, but we should really train people that they can digest high quality food.
Yeah, I think this is just in line what Mervyn from Ireland says. I think the emphasis should be on quality and trustworthiness, but not timeliness, although official statistics could be made more timely using new techniques.
Sure, it's not either or. So I think we have learned that timeliness can tremendously improve without jeopardizing, let's say, equality, or with a better mix, a kind of, let's say, Pareto optimum, where quality is reduced a little bit in terms of reliability and revision rate, but only to such an amount which is acceptable to the users. If you sometimes communication is the solution. If you say, okay, what would you say if your GDP would arrive 30 days earlier, your quarterly GDP, or your inflation rate 30 days earlier? You would certainly have to calculate that we have to revise it more often. It's not exactly the same quality, but in terms of market relevance, can you accept this? And then many users would say, after consideration, yes, this is fine for me.
Okay. Now I will return to the issue of dissemination of microdata, so raw data.
Yes.
We have a question from Germany. For me, also more microdata or so-called raw data should be available for people who want to work with the data. Plus, it would be wonderful if the national statistics of different countries work more together so that the data quality rises. And related to this is another question from Mexico. What about the standardization of the microdata? It could help to make use of them further than in national accounts, so beyond national accounts.
Yeah, okay.
Yeah, so these are two questions related
let me first make a distinction, which is quite important, namely a distinction between the statisticians within the community of statistical offices, and then the people outside of this camp, so to say, right? So there is one question, which is the exchange of microdata between statistical offices. And this was discussed up and down for 5 years within the European statistical system. And a solution was found in the first place for external trade data, which are now exchanged between all the 28. But you cannot imagine how difficult it was, because you have to protect let's say, the privacy of your data, even if we talk only about external trade, which is not that super sensitive. So we are not talking about income or health or so. But the first is exchange of microdata among statistical offices. And the second is access to microdata for scientific people, for example, or for people, teachers. If we talk about the second group, then this is really then the world where we have made many progresses. Unfortunately, not that much progress as the scientific people would like to see. Nevertheless, I think the world now is much better than 10 years ago, because you have remote access to microdata, you have safe rooms or secured rooms where scientific people can go to the statistical office and have access to locked data and. So there are many possibilities to have access to data. And I think that the combination of technical algorithms, mathematical algorithms, and legal protectors are a good solution which will further develop in the future, so that further improvements can be granted for scientific people who want to work with the pure raw microdata. Third one is the question of standardization. And here, yes, to a certain degree, I think you can standardize. And then we are talking about things like public use files or for education and schools, or scientific use files, which are standardized use files from the big household surveys, for example. This can be done and it should be more widely used. Yes.
Okay, thank you. And I think we'll just take one more question. What is your opinion about the widespread adoption of the UNEC generic statistical business process model as the basis for the statistical process models of each national statistical office?
Well, yes, so good news and bad news. The good news is, I think that once you have designed a statistical process, once you have defined one spine, one spaghetti in the bowl of spaghettis, which is a business process, once you have done this, then the GSPPM is a good standardized approach. For this question, yes. But for the question, what is a business process? Which one needs to be individualized and cut into one spaghetti? There, the GSPPM does not give you an answer at all. Because if you want to cluster different statistics in one production environment, with a data warehouse in the middle, for example, and, these are questions which go much beyond the GSPPM. So it's only for one single process, it is a good, I think, standard process model. But for the overall architecture of the enterprise called Statistical Factory, it doesn't give you an answer at all.
Okay, thank you. We don't have any more questions, but this is also okay because it's nearly 5:30. So I would really like to thank you for this insightful lecture, and many thanks to our participants for their active participation, for really interesting questions. And we already sent a link to your inbox to a very short survey about today's webinar. Although this is the last webinar in this year's series, we plan to have a next series of EMOS webinars, so we would really appreciate your feedback. Now, you also already received the presentation file with our reminder, but you can also download the file here in case you missed it. And we'll leave the room open for another 10 minutes or so, and we'll also publish the link to the recording of this session on our website, probably already tomorrow. So I'd like to thank once more to actually all presenters, to today's presenter especially, but also to other presenters in the EMOS series in 2018, and participants who joined us from so many different places around the world. So thanks also to Eurostat for financially supporting this activity, and my team here in Ljubljana that devoted so much time and energy to run these webinars as smoothly as possible. So thank you and goodbye for now from Ljubljana. Bye.
Thank you also from Wiesbaden.
Yeah. Bye-bye.
Goodbye.